This is section 5.4, exponential functions, differentiation. So the natural exponential function is f of x equals e to the x. This is the inverse of the natural logarithm that we talked about last time. We said logarithms are the slowest growing, so naturally exponentials are going to be the fastest growing because they are opposites. So if we look at solving exponential equations, we want to use natural logs and e to cancel each other out. So what that looks like, so we have 7 equals e to the x plus 1. Okay, simplify to try to get x by itself as much as possible. So we have 6 is equal to e to the x. So we are going to take the natural log of both sides. So ln of 6 is the ln of e to the x. We know that using logarithm rules, this x can come down in front times the natural log of e. The natural log of e is just 1, so x equals the natural log of 6. All right, let's look at going the other direction, getting rid of a natural log. So we have the natural log of 2x minus 3 is equal to 5. We're gonna raise each side. We're gonna use that, each side is the exponent, so we're gonna do e to the natural log of 2x minus 3 is equal to e to the 5th. E to the natural log cancels out, so we're left with 2x minus 3 equals e to the 5th. And then we solve for x. Don't worry about plugging e to the 5th into your calculator to get a number. So 2x equals e to the 5th plus 3, and then divide by 2. So x equals e to the 5th plus 3 all over 2. A reminder of Algebra 1, operations with exponential functions. If you are multiplying, this should have a multiplying in the middle. So e to the a times e to the b. If they have the same base, you can just add their exponents. Same thing with division. If they have the same base, you subtract their exponents. So let's find, we're going to do derivatives now. So the derivative of e to the u is e to the u times the derivative of u. So let's see what that looks like. So if we have e to the 2x minus 1, so d dx of e to the 2x minus 1, in this case u is that 2x minus 1. So we rewrite it, e to the 2x minus 1, and then we multiply by the derivative of the exponent. In this case, the derivative of the exponent is 2, and then I'm just going to rewrite that to be 2e to the 2x minus 1. Let's try another one, d dx of e to the negative 3 over x. We rewrite it, e to the negative 3 over x, times the derivative of negative 3 over x. Remember, negative 3 over x is like negative 3x to the negative 1. So our derivative is positive 3x to the negative 2. So times 3 over x squared. If you want, you can write that 3e to the negative 3 over x squared. Either of those are acceptable. And last one, e to the ln of 7x squared. We're taking the derivative. But first, let's simplify, because e and the ln should cancel out. So that's the same thing as taking the derivative of 7x squared, which we know is just 14x.